Since the dawn of humankind, we've always looked up at the night sky and wondered, what lies beyond the stars? What mysteries do the heavens hold? And as our ancestors gazed at the moon, could they have ever imagined that one day we wouldn't just explore space, we'd mine it? In today's video, we're diving into the history of space exploration and how it's laid the foundation for the next frontier, space mining. From the early days of the space race to modern technologies that could change the way we think about resources, we'll explore how our steps into space have led us to the brink of extracting valuable materials from asteroids, the moon, and beyond. But to understand the future of space mining, we have to start at the beginning. Space exploration didn't just begin with Apollo 11 and humans walking on the moon. It all started much earlier. The seeds of space exploration were sown during World War II with the development of rockets, deadly at first, but eventually they became tools of discovery. In the 1950s, a brilliant group of scientists, many former military engineers, began developing rockets for peaceful purposes. Their work led to the launch of Sputnik in 1957, the world's first artificial satellite sent into orbit by the Soviet Union. The space race had officially begun. Suddenly, the impossible seemed possible. If we could send a satellite into space, what else could we do? It wasn't long before the United States, the Soviet Union, and other nations set their sights higher. This was the start of a massive leap forward, one that would eventually lay the groundwork for space mining. By the 1960s, the space race was in full swing. In 1961, Yuri Gagarin became the first human to orbit the Earth. The stakes couldn't have been higher. And then, in 1969, Neil Armstrong took that first historic step on the moon.
That's one small step for man, one giant leap for mankind.
Humanity had touched another world. But while the Apollo missions were largely about exploration and demonstrating human ingenuity, they also had another side, the study of lunar resources. During the Apollo missions, astronauts collected hundreds of pounds of lunar soil and rock samples. These were more than just souvenirs. They were the first step toward understanding what resources lay beneath the surface of other worlds. The moon's rocks revealed traces of minerals that exist in abundance back on Earth, but there was something else. Among the lunar samples, scientists discovered something that sparked their curiosity: helium-3. This rare isotope, thought to be abundant on the moon, could one day serve as a powerful fuel for nuclear fusion, a clean, nearly limitless energy source. It was then that the idea of using space not just for exploration but for resource extraction started to take root. But the moon is just the beginning. The real treasure troves may lie even farther out, in the asteroid belt. And no, we're not talking about movie-like scenarios with giant rocks crashing into Earth. Asteroids are ancient remnants of our solar system's formation, and many of them contain precious metals like platinum, gold, and nickel. Some even contain water, which in space is worth more than gold. These celestial bodies are the keys to space mining's future. Mining just a single asteroid could yield trillions of dollars in resources. That's more than the entire global economy in a year. But how did we get to the point where mining these space rocks even became possible? The years after Apollo were marked by a shift in space exploration. Instead of bold missions to the moon, focus turned toward building infrastructure in space, like the International Space Station, and advancing the technologies needed to support human life off-world. Space technology advanced by leaps and bounds. Better rockets, improved robotics, autonomous systems, and more efficient propulsion methods. These technologies are crucial to space mining. Why? Because mining an asteroid or another celestial body is not just about sending humans up there with pickaxes. It's about sending autonomous robots, building machinery that can withstand extreme conditions, and even creating habitats where humans could live and work off the planet. So here we are. Space exploration has given us the tools, the knowledge, and the vision to make space mining a reality. In the near future, companies and nations alike will launch missions to extract resources from space. These resources could fuel not only our space missions, but also help solve resource shortages here on Earth. Space mining is no longer just science fiction. It's becoming science fact. And it's all thanks to the history of space exploration, a journey that began with a simple satellite, and has led us to the brink of a new age. An age where the resources of the cosmos are within our grasp. The path to space mining has been long, filled with innovation, setbacks, and triumphs. As we look ahead, one thing is clear. The future of humanity is tied to the stars. So, what do you think? Are we ready for the age of space mining? Let us know in the comments below, and if you enjoyed this journey through the history of space exploration, don't forget to like, share, and subscribe for more exciting space content. Thanks for watching.